Bismillahirrahmanirrahim. This is our hybrid renewable energy system that we want to optimize. It consists of a wind turbine, a solar system, a solar plant connected to the grid. It has a reschedulable load connected here. So we have to optimize the size of this wind turbine, the size of this solar plant connected to this grid, and we have to meet this load demand. At the end, we have to optimize the cost of the energy, levelized cost LCOE, the levelized cost of energy that's being supplied to this load, or the energy being generated by this renewable energy system. So first of all, our priority will be to meet this load demand through this renewable energy sources, that's wind turbine and a solar system. In case when this renewable energy is not sufficient to meet the load demand, then this energy will be taken from the grid to meet this load demand. So this is the main operational strategy of this operating system, that first priority will be given to renewable energy system, and later on if there is a deficient demand, then it will be taken from this grid. On the other hand, if there is an excess energy available during the daytime or excess wind energy available even at the night, then that energy after meeting this load demand will be sold to this grid. So our main point, our discussion here is load optimization of this system with respect to load management. We have to reschedule this load demand. Going into the detail of this load demand, here it is. So actually this is a load demand over 24 hours. It can be observed that this color, this one is the fixed load, these two columns are the fixed load. It means this load cannot be rescheduled. We have to meet this load demand and these specific hours. So these are the basic needs, the basic load, basic fixed load that has to be operated at these specific hour. For example, the fixed load has to be operated from 8 to 16 hours, and in this pattern, and this other fixed load has to be operated through 24 hour in this with this specific load on each hour. There an other load, so it's called a fixed load. So we have to meet, we have no choice to reschedule it. We have a little choice to reschedule the shiftable profile load. So in this shiftable profile load, this yellow color, so I have a choice to change the starting hour of this one, because in this case here is 8th hour is the starting point of this load. So it can be shifted from this 8th hour to any hour. Let's suppose 3rd hour. Sorry, it can be from this 8th hour, it can be changed, shifted to any, suppose 3rd hour or any other hour. So it can be changed from this 8th hour to this 2nd hour or whatever. What is this? Copying it from. So I'm changing it to the 4th hour. So this load can be changed, but the sequence of this operation, I can only change the starting hour of this load. I cannot change the profile of this load. So it's a shiftable profile. I cannot change the magnitude of this hour. It should be in the same pattern, in the same magnitude. So even I can copy this one and I can move at the end of this. So I'm starting it this load from 15th hour. So it's depending upon the extra energy available, how much the energy is available. So I can assign a duty to the optimization algorithm keeping in view the optimized costs of the energy production to decide this starting R. So I will this will be decided by an optimization algorithm. What should be the starting R? So optimization algorithm will tell me what should be. It will give me a number 4, 3, 2, whatever, to suppose start from this point, suppose optimization algorithm give me a number start from 9th R. So this load will be simply shifted to this 9th R in the same pattern. So the starting R of this can be decided by the optimization algorithm. There may be some other hundreds of techniques to manage this load, but I am managing in this way that the starting R should be can be decided by the optimization algorithm. So we have a choice. The remaining is load 1, load 2 and load 4, because load 1 and load 4 it should be a load 5. So these two are fixed loads, and this third one is a shiftable profile. I can change the starting R of the R, but cannot change this arrangement. Cannot change this arrangement. I can only change the starting R. So I can drift this whole load profile. So load 1, load 2 and this load 5th, this is a shift volume profile. I have a choice to manage this load, to operate this specific load at any R without any arrangement, without any order. So I have a choice for these 3 loads, these green loads. So these are the actually shiftable volume profile. For example, just an example. So this volume is fixed, this one is fixed. Suppose my optimization algorithm give me to start from 13. How it will be decided? So operational strategy is another side. I'm just talking how should be it's implemented. So it is started from 13 R. So the whole load is shifted in this in the same order from R number 13, and the remaining is this load 1, load 2 and load 4. Again this will be load 5. So I have to manage this load 1, load 2 and load 5. So you can see this in the night when there is a small energy available. I have to meet this fixed load, and the extra energy, if it's available, that's used for this to manage this small load. So our first priority is, if there is extra renewable energy available, we have to meet this load 1 because it's of largest magnitude. If there is not sufficient renewable energy available, then we will check if the extra energy can be used to turn on this load 5, that's of small magnitude 4.5. Even still, if it cannot turn on this load, we will check if it can, the third lowest load, this 1.87. So later on I will match this with the code how this is being implemented. So you can see in the daytime when there is sufficient renewable energy available, so in the solar energy is available, so this load 1 is being turned on, this of high magnitude. At the same time this load 5 is being turned on because in the daytime the renewable solar energy is available, so that's used. So these loads are managed in this daytime, and you can see this can be even easily met by the wind turbine even at the night. So you can see this is given a priority to this one. So the remaining load that cannot be met at the night time by this renewable energy source, so it's most probably it will be taken from the grid, as at night the solar is not available and the wind may not be available to feed this one. So if there is sufficient renewable is available, so it will be taken, otherwise it has to be, we have to take energy from the grid to meet this load demand. The only thing that you should, so whatever way you manage it, but this in 24 hour, this total load, whatever is the magnitude, it should be met within 24 hour. It doesn't matter what order you are using, in which hour you are meeting it, it doesn't matter. It is totally your choice. So moving to the code. So here is the main file. In the main file, this is clear close. So number of variables that we want to optimize. So there are 3 variables. So later on we will discuss what are the 3 variables. So the first variable is the size of the wind. The second is the size of the solar should be optimized. And our third variable is starting hour of the shiftable profile load. So this starting hour will be to the from where it should be the starting hour. This will be decided by this algorithm. So this is the lower bound 111 and the upper bound of these solar wind size and starting profile. Why I put here 18? Because the size of this is 7, and if I put it beyond 18, then it will not be able to meet this load demand till 24, because 18 plus 7 is 24. So at the upper bound is 18 hour, after 18 not allowed after 18. So at minimum it should be 18 hour before 18. So this is our fitness function. We will discuss this economic analysis file. This is our fitness function in detail. So these are just genetic algorithm parameters. You can about genetic algorithm, you can in literature, a lot of literature is available. So number of population are 30. Even you can increase this, the number of iteration. There is the crossover index, distribution of mutation index. You can change all these. So probability, crossover probability, mutation probability. So here we are calling the optimization algorithm genetic algorithm. We are giving as fitness function the lower bound, the upper bound, the population, and these genetic algorithm parameters. At the output, it's giving us the best solution. Means x1, the x that consists of x1, x2 and x3. x1 is the size of wind turbine, x2 is the size of this solar, and x3 is the size of this the starting hour of this shiftable profile. So this is actually x, and here we are plotting this fitness curve, our objective function. And here at the end, just is we are calling a plot statistic function that's actually using for displaying the results and for plotting the different results. So moving toward the economic analysis, this is our fitness function. So actually this fitness function is responsible for optimizing the size of this wind, solar and starting hour. So this optimization algorithm will be calling this fitness function to decide the size of this wind, solar and starting hour. So it will be calling the economic analysis, and economic analysis will return the fitness value. So fitness value in our case is levelized cost of energy. So different x parameters will be entered here, and this fitness function will return levelized cost of energy, this LCOE. So based on this LCOE, x1, x2 and x3 means the size of the wind, the size of the solar and the size of the starting hour, what should be the starting hour is decided. So here it is just some parameters we are loading the data. So it consists of your installation or your location G, means solar irradiation, wind velocity, temperature, and there are some different variables. Here we have du1, dut. Let me check. So here the du1 count, du2 count, fu count. These are some parameters. Means how much, for how much hours this du1 is required, is operated. du2 is operated for how many hours, ff is operated. These are all manageable, reschedulable load. Shiftable profile is managed by the optimization algorithm itself. So this is the du load, that's 4.73. This du2 is 1.87 and ff load is 4.5. So initially the counts for how much hours this should D1 count, DUT count. Initially it's 0. For maximum hours, DU should be operated for 16 hours, because you can see here the operational of this is for 16 hours. So maximum DU1 count should be 16. Similarly, this DU2 count should be maximum for 16, should not beyond 16. Similarly, this FF count should be 8, not more than, should not be operated. So this FF, the third one is, this last one is, this is the 8. This should not be operated beyond 8 hours, because this is the maximum limit. Yes. So this is here is the wind turbine modeling. I will provide a literature that will consist of this wind turbine modeling. You can see how the formulas, so how this wind turbine can be calculated. So this size of the wind turbine, it's equal to x1. x1 is being decided by the optimization algorithm. Give us the size of the number of wind turbines, and each wind turbine is of 10 kilowatt. Is the hub height of the wind turbine. This is the reference, at which reference height we are taking this velocity. As we are taking this velocity from a meteorological site, so at which height this sensor is installed to measure the velocity. So minimum and cutoff and rated velocities of this wind turbine, and this is just formula you can find in literature. I will also share with a table, that's the modeling of this wind turbine. You can easily see how this is implemented. So finally, each wind turbine is of wind turbine, number of wind turbine, and for 1 kilowatt wind turbine, what's the power? So multiplying it by the number of wind turbine, and each wind turbine is of 10 kilowatt. Similarly, here is the this is the solar section. In the same way, I will also share the formula for this calculation of this. So this is just a parameter, a variable to calculate this term. This one, 25 is the reference temperature at which we are being calculated this power with respect to this ambient temperature. So here is total number of solars, each of has a 1 kilowatt, number of solars being selected by this. So here, and solar x2 is also selected by the optimization algorithm. So G is the solar irradiance divided by 1000 to convert it to kilowatts, and here it is just a parameter factor we have calculated here. So I will share a formula with this for solar modeling. You will see how this being implemented. You can see it, it's not a problem. So x3 here is the starting hour. So what should be the starting hour?